I'd once again like to welcome Prith Banerjee, the Chief Technology Officer of ANSYS, for a special panel with other CTOs.
Welcome to Simulation World. Simulation World is world's largest virtual event for research and development leaders and engineering simulation thought leaders across industries. We have more than 20,000 attendees registered for the event, and many of them are attending this panel. My name is Prith Banerjee, and I'm CTO of ANSYS, the global leader in engineering simulation software. I joined ANSYS about 2 years ago after serving as CTO at ABB and Schneider Electric and as director of HP Labs. I used to be a customer and user of ANSYS simulation tools. Now it is my pleasure to work with my colleagues to help set the directions for our long-term technology strategy. ANSYS helps companies around the world design and develop the most amazing products, from computer chips to rocket ships. Companies use our technology to engineer and test products completely in the digital domain, without the need for costly and error-prone physical prototyping and experimentation. We call this approach simulation-based virtual prototyping. As a result, we enable our customers to drive top-line revenue by designing better products and bottom-line savings by reducing the cost of R&D. Our customers are the most innovative companies in the world, in industries as diverse as high-tech and semiconductor, automotive, aerospace and defense, industrial, and energy. These companies are trying to solve incredibly complex problems in areas like 5G, autonomy, electrification, and industrial Internet of Things. The laws of physics are absolute, and when they are delivered through simulation, engineers can see with clarity and certainty what's ahead. Simulation gives you the ability to predict how something will behave in the real world. Simulation gives you the confidence to build a product virtually without the need for costly and time-sensitive physical prototypes. Simulation enables you to engineer what's ahead. Engineering simulation is more relevant than ever today. This 45-minute panel will be on simulation-based product innovation in the digital world. And we have an outstanding set of panelists today. We have on our panel Sujit Chand, the CTO of Rockwell, Suresh Venkatararayu, CTO at Honeywell, Malik Tatimapula, CTO at Ericsson, Sudhi Bangalore, the Global Vice President of Industry 4.0 at Stanley Black & Decker, and Ed Abo, the President and CTO at C3.ai. So panelists, welcome to our panel. I'm going to get started by a little bit of introduction. So Sujit, would you mind introducing yourself, your company, Rockwell, and sort of your role within Rockwell? Sujit?
Yeah, my role at Rockwell Automation is to lead technical innovation and global business development. Rockwell Automation, for those of you who are not familiar, is the world's largest company dedicated 100% to industrial automation and information. I've been in the automation business for a little over 30 years, and I can tell you that this is probably the most exciting time to be in industrial automation. With trends such as IT-OT convergence and digitization, the role of simulation is changing dramatically. Simulation used to be mostly on the design side in manufacturing. Now it can have a very significant impact in the operations and maintenance cycles as well. I'm excited to be on this panel, and I'm looking forward to the discussion.
Thank you, Sujit. Suresh, would you introduce yourself and your role within Honeywell?
Good afternoon, everyone. Suresh Venkatararayu, CTO Honeywell. Been with the company for 25 years, and I oversee both technology, R&D, and product development across our 4 lines of businesses, and also our digital business, which is Honeywell Forge and Honeywell Connected Enterprise. For me, it's an important platform to be with all of you to discuss about simulation and the role of simulation. The reason is we're going to talk about the transformation we're going through from product, connected product, autonomous product. The evolution can only happen if simulation and digital twin has to intervene and play an important role. It's the most important topic. Happy to be here.
Thank you, Suresh. Malik, we're going to go with you next. If you can introduce yourself and your role within Ericsson.
Good afternoon, Preet. Good afternoon, everyone. My name is Malik Tadipamla. I'm a CTO of Ericsson Silicon Valley. Just introduced about Ericsson. Ericsson is the leader in mobile networking infrastructure. In fact, we are the innovators and the leaders in 5G networking. 5G, unlike the previous generations, is causing a paradigm shift in bringing various industries together: telco, cloud, industrial IoT verticals, and media and entertainment. So these are the exciting times to drive the innovation and forward-looking strategy on what needs to be done as next, as we see the AI machine learning technologies, SDN and FE, edge compute, IoT, security, all of them are getting integrated on top of 5G networks. So my role at Ericsson is to really think about what next, how these technologies are coming together to address some of the critical use cases for the convergence of these industries, so-called telco, cloud providers, and industrial IoT verticals.
So, Sudhi, why don't you tell us about your personal background and your role within Stanley Black & Decker and about the company itself?
Fantastic. So thank you so much, Preet, for having me on the panel. My background has been technology transformation around operations, around factories for the last 23 years. And in my role as the Global Vice President of Stanley Black & Decker, that's exactly what we're doing. We have a large landscape of factories and DCs, about 140 in number. And my role is to drive the vision and the transformation of these factories at scale. And we are at about a year and a half into the program and in scale-up mode as we speak. So it's an exciting time to be around technology and manufacturing, as Sujit outlined. So excited to contribute to this discussion around the role of simulation in terms of how it's going to help us drive additional value that we have not experienced within our factories, even though we've used simulation extensively within our product design.
Thank you so much, Sudhi. And then finally, we'll go to Ed, who's the president and CTO at C3. So Ed, why don't you introduce yourself, your background, a little bit of C3 for our audience?
Sure thing, Prith. First, thanks for including me on the panel. And I am the Chief Technology Officer over at C3 AI. This is actually my fourth decade in information technology, but I actually started as an engineer in mechanical aerospace controls, and so the topic of simulation is near and dear to my heart. Let me net out C3 AI for you. We provide an AI platform for enterprises to deploy machine learning technologies to improve their operations, to improve customer delivery, customer engagement. And we're very fortunate to have companies like Royal Dutch Shell, 3M, Department of Defense, U.S. Air Force, and as well as Baker Hughes in the oil and gas business. And the platform that we provide allows companies to rapidly design, develop AI applications and deploy them across an enterprise. This sits on top of Microsoft Azure. It sits on AWS. It can run on-premise or on the edge. And our customers basically are looking to deploy tens or hundreds of AI applications to improve their business. But thank you for including us, Brett.
Thank you, Ed. So as we look at sort of simulation and ANSYS and so on, right? I mean, we internally at ANSYS have been talking to many customers about the role of simulation. And when I started as a graduate student and when I was in academia, we saw simulation used to be restricted to the analysis phase, right? So you look at the number of maybe 100 engineers in a company, about 2% of engineers oftentimes use the detailed simulation, sort of the sort of 3D simulation that we are talking about, right? But increasingly, we are seeing the role of simulation in the ideation phase, where as soon as you enter a design in a CAD, right, is there a role for simulation, for do a quick simulation to see the impact of simulation, so that you can do design space exploration? Or in the area of manufacturing, right, as people are doing more, say, additive manufacturing and so on, there's a potential role of sort of simulation in manufacturing. Then as you go into the product life cycle of an operation, right, you have products, and essentially you have a product in operation connected to IoT, and so there is a potential role for simulation with simulation-based digital twins and so on. So we are seeing increasingly simulation being used in all stages of a product life cycle. So I'd like you, Suresh, to kind of talk about the role of simulation in your company, right, and in Honeywell, to see what is the role of simulation in the process of designing your most innovative products, analyzing your products, manufacturing your products, operating your products. I mean, you and I, when we chatted last time, we were talking about the new product introductions and so on. So talk about the role of simulation as well.
Right. The way I would characterize the art of our products in three different ways. One, a classic product which is not connected. It could be it could be your APU, an engine, or things that are not real time connected. The second one, I would characterize them as a connected product. The third one, I would characterize them as an autonomous system. Either I'm building a robotic system or an unmanned vehicle. All three has a different application of simulation and why we use and where we use. If you take a critical product today, every designer, I'm a designer, I would love to really use this to really drive what if analysis. I would like to really have an alternative design patterns. I would like to really validate my hypothesis early stages so that I can actually really ensure that I have an alternatives in place. If I'm a manager of that particular product business, I log significant amount of early detection of any issues that I'm actually leaking. And I think that we drive, and I think today from CAD, CAM, simulation, integrated life cycle, I think that we continue to drive. When you really move into a connected product, we would love to really get the data back from our install base. We want to really reanalyze the data to understand if there are product failures, predictive performances or assuring asset performances. We need those data to really re-inject that back into a simulated product to understand and ensure how we can really solve that whole performance of assets that we have actually provided back to our customers. And the last category is it starts from a simulated platform. You can't build a huge robotic platform, walk into a customer to say that I can actually meet your spec. The day one, the discussion starts with a simulated platform, physics-based simulator, taking those spec and parameters, ensuring that the spec operates at an optimum level, and then use the simulated platform to start designing your product. And then basically you build your physical twin or your digital twin. So all three characterization, I think the maturity is evolving everywhere. We are starting to see our maturity evolve. I think I see the most definite path why simulation is important element for us to innovate and design for the future.
Thank you so much, Suresh. So Malik, at Ericsson, right? How has the role of simulation at Ericsson evolved over the years, and where is it today?
Sure, Preeta, I think Suresh put it nicely, validating hypothesis. In our world, whenever there is a transition from one generation to the next generation of technologies in the mobile world, we do use simulation extensively in understanding the real world performance of the technologies that we are introducing. So let me give an example of how we are using simulations in the 5G world, right? So 5G is not just incremental upgrade to 4G. In fact, 5G uses or introduces a number of new technologies, mostly in the context of radio. So when it comes to 5G, we have new base stations using new radio technologies such as massive MIMO, massive multiple input, multiple output technologies to really multiply radio link capacity. At the same time, it introduces technologies like beamforming to focus a signal from the transmitter to receiver. At the same time, 5G introduces new frequency bands. We call it as mid-band, sub-6 gigahertz, or even high bands, which is millimeter wave, 26 gigahertz and above. And then you also have new devices, so-called smartphones, operating at different frequency bands. So you can see we have got devices such as smartphones that are 5G capable, operating at new frequency bands. You got the base stations that are coming up with new radio technologies. Then you got air interface in between. So how do you simulate these components to really understand what's the real world performance of 5G technology in terms of capacity, coverage, and other parameters in terms of latency, delay, in understanding how 5G offers that user experience compared to 4G or any other technology. So we do use simulations extensively to model these devices, air interface, and then base stations based on these new technologies and what's the corresponding real-world performance compared to 4G.
Thank you so much, Malik. That was really great. So Sudhi, you kind of, as part of the introduction, you mentioned some of the things that you're driving at Stanley Black & Decker. But can you talk about the role of simulation at Stanley?
Yes. So one of the things I didn't mention is in terms of what we do at Stanley Black & Decker, we're the largest tool company in the world. And we're the second largest security company in the world. And we have a lot of focused solutions around fastening systems. We supply to some of the biggest and largest automotive companies. So traditionally, we've used simulation like more on the product realm of things. So we would use it to think of the art of the possible from a design standpoint, usability standpoint, and of course, performance. What we're now doing with Industry 4.0 and the concept of digital twins, we're now using that both physics-based and AI-based simulation, a combination of both of these technologies to really understand how we can obviously predict the ability to understand when the assets will go down. When I say assets, I'm talking about assets on the factory floor. Those are molding machines, machining assets, and assembly, and on, furnaces. So we're talking tens of thousands of assets across all of our factories. So our ability to get the granular understanding of when it'll go down and what parts, pieces of those assets are contributing to the breakdown is really important. So that's one set of opportunities or use cases that we're working on, and we want to do it at scale. It's not good enough just to do that in one or two or three big factories, but the big opportunity is how do you actually use technology to hunt for these opportunities where we can prevent the downtime of these machines, and so we can have better consistency in our operations and lower, obviously, cost of downtime. The other opportunity, which is even bigger than that, is to optimize our output. So whether it is, again, a molding type of operation or a machining, whatever the case may be, how do you actually optimize to a benchmark level, which is much better than fleet average, right? So just to summarize, just those two buckets of opportunities is worth hundreds of millions of dollars for a large company such as Stanley Black & Decker. So the goal is not, again, to just simulate it in pockets in one or two factories at a few hundred assets, but it's just to do it at scale and make it self-sustaining. So that really is the prize that we're going after at Stanley Black & Decker.
Fantastic. Wow, that is a great vision. Well, actually, that is a great lead into to Ed, right? So kind of Ed mentioned that C3 AI, they're essentially using the same AI technology as he talked about. So Ed, why don't you kind of talk to the area of sort of how is C3 enabling companies to sort of combine the art of simulation with the art of AI?
Yeah, and just to build up on what Sudhu was saying, I mean, you can start with looking at a piece of equipment and really complementing the engineering design, engineering simulation with its empirical data or empirical behavior. And so the combination of an engineering-based model, if you will, together with the real-world behavior, which, as this audience knows, captures the nonlinearities, is a very powerful combination. But when we then expand this out, we can start to look at more complex systems, and that might be like a refinery in downstream oil and gas, or it might be actually a supply chain. And that's where things get really interesting, where you're training these deep learning models on looking at not just a piece of equipment, but you're looking at the system and the entire behavior of the interplay of the subsystems, if you will, to improve production, yield, to improve reliability of those equipment, of the operation, if you will. And then you can take it at even a broader scale, where you're looking at improving a manufacturer's on-time and full delivery. And what you're doing there is you're basically keeping a finger on the pulse on the demand, and then you're also looking at the supply and simulating various scenarios so that you can continue to deliver to the customer products on time and full, and mitigating for supply disruptions, which is a very topical problem these days, and really addressing it. So simulation really plays a role from the discrete unit all the way to the end-to-end value chain of companies, and that's basically what we're doing at 3M or at Shell or the Air Force to improve availability and readiness of aircraft.
Absolutely, thank you, Ed. Actually, that very nicely leads into to Sujit, right, at Rockwell, right, as sort of the leading automation company in the world, right? Essentially, I mean, in your introduction, Sujit, you kind of mentioned some of these things. So Sujit, why don't you talk about sort of the changing roles of simulation, right, in a company like Rockwell? You're on mute.
Since World War II, simulation has been used extensively. I'm going to focus my comments on physics-based simulation. I agree with the other panelists, even within Rockwell Automation. Of course, we've been using simulation extensively for many, many years, but physics-based simulation is relatively new. And I'll give you a couple of examples. We design a lot of printed circuit boards, and some of these printed circuit boards have components that generate a fair amount of heat. For example, IGBTs that are used in drives. And today we use ANSYS tools, we use CFD analysis to simulate the thermal signatures on the printed circuit board. It not only allows us to optimize how we lay out the components on the board during design, but it also helps us better design heat sinks for getting the heat out of the board. Because in many of the products that we make today, we don't like to put fans for cooling because that introduces a single point of failure. So we've really ramped up on the use of physics-based simulation tools for thermal analysis of printed circuit boards. Another new area that we've applied physics-based simulation is in our factories. When we make these printed circuit boards, we are grabbing integrated circuits at very, very high speed and depositing these on the boards. The machine that grabs these chips and puts these chips on the boards fails occasionally. And when it fails, we generate a lot of scrap because if the components are not placed accurately on the board becomes scrap. And the machine has to stop and you have to kind of reset everything. Again, we're applying ANSYS tools in this case in real time, which we have never done in the past. And this is only possible because with IT-OT convergence and reduced order models, we can run a lot of these complex models at the edge. So this is another great example of how we are driving the use of physics-based simulation in what we do at Rockwell Automation.
Thank you. Actually, thank you all the panelists. This was a fantastic sort of introduction to the next question I'm going to ask all of you. So in our current world, everybody talks about digital transformation and using a lot of digital technologies in our world, right? So we talk about, when we say digital technologies, we mean AI and machine learning. We mean big data analytics. We mean IoT and 5G and cloud and mobility, all those kind of the latest technologies, right, in our field side. So I would like you to kind of pause and think about the challenges that these digital technologies provide, as well as the opportunities, right? So I'm going to start with you, Malik, right? So talk about some of the challenges and opportunities about using digital technologies at Ericsson.
Absolutely, Preet. So at high level, let's look at the transitions that happen in the wireless industry, right? Moving to 3G, it was a convergence of mobile and IP. That's how we introduced mobile internet. 4G further extended to provide mobile broadband. But 5G is essentially an integration or convergence of mobile and the cloud. That brings up very interesting challenges and opportunities. So there are a couple of things I can quote. The 5G is moving towards cloud native. What does cloud native means? Essentially, we want to move from monolithic applications to more microservices. We want to move from a lot more slow application development to rapid application development. So that has got certain challenges and opportunities. Challenges being, now we are moving from waterfall methods to more continuous integration, continuous delivery methods. We are moving from net operations to more DevOps kind of automation aspects. We are also moving from the classic monolithic applications to more container-based microservices. So that's one aspect of cloud native. Then the second one is more on the AI machine learning side, how AI machine learning can help. As the 5G provides more and more opportunities to extend the use cases, it also creates a complexity. So how do we take AI to not only automate, but also extend AI capabilities to come up with certain actionable insights for predictive repair and maintenance aspects to implement within 5G network? So I would say these are the two interesting things that we see major aspects to look at: cloud native in combination with AI machine learning for 5G.
Thank you, Malik. Thank you. So, Sudhi, when you were sort of introducing your role as driving Industry 4.0 and so on, right, in their role in sort of operations, you kind of hinted at this, but I would like you to expand on your thoughts on the challenges and opportunities of digital at Stanley.
Sure.
Sudhi?
Yes. One of the backdrop, an aspect of the backdrop that's important to this conversation is when you're talking about factories and all the things Sujit talked about, that typically happens in a more advanced factory. But in a large industrial company like Stanley Black & Decker, we have this phenomenon of lazy, rusty assets, essentially legacy assets, where the first problem is becomes how do you actually garner data or gather data? That itself is a foundational problem. So if you really want to drive transformation at scale, which is what we want to do, at least 80% of our factories we want to transform, which is a large swath of factories. And for us to do that, we have to take care of all of the older genre of assets, as well as obviously the newer factories, the newer genre of assets. So that itself is a huge problem. Being able to address that aspect is not a trivial challenge, given all of the geographical constraints and on and on. So that it takes a while to crack that nut, and we're almost in the process of completing and addressing the challenge. Not there fully yet. The second aspect is the people component, especially with this new crisis of COVID. It has brought shined the light on the fact that a lot of our factories has huge dependencies on supply chain aspects outside of the U.S. And so being able to bring that capacity back into the States and being able to upskill and transform our people is a huge challenge, right? And you cannot just train people just on technology. It's also to see how we can find new career paths, and how do you make it systemic in nature, so people can really think of it as again another attractive career option, which it is not today. So long story short, the people component of this is a big challenge and a big opportunity. And so to do that, one of the things we've done in Stanley Black & Decker is to show and demonstrate the art of the possible. So we've actually stood up a brand new advanced manufacturing center geared primarily to demonstrate what's possible. We want people in our factories to come touch it, feel it, and right in the heart of downtown. It's a commitment we made to the state of Connecticut and to the city of Hartford, a mecca of manufacturing when it first started a couple hundred years back. So what we're doing is to articulate and demonstrate what's possible. So those are two big challenges. Essentially what it means is not only will you transform, when you address these challenges, then the value capture, we call it as value capture, which is both cost takeout, bringing new opportunities to the people, and also get a competitive edge. You got to do things in scale. When we do that, we think there's hundreds of millions of dollars of value capture just for Stanley Black & Decker and our people. And when we do this and are successful in the next year and a half or so, then I think we'll have also demonstrated and set up a blueprint for other manufacturing industries to follow. And to that end, I want to say that we cannot do this alone. One of the other important things that we've done is to stitch together an ecosystem. Again, an overused term, but in this case, we've got both big and smaller companies, including Rockwell, who's a great partner for us, working with Sujit and his team. They're helping us, get to the end point as soon as we can, while creating a blueprint that other people can use.
Fantastic. So Ed, I mean, sort of this question is about digital technologies and so on, and at C3AI, you are driving a lot of these digital technologies. So what are your thoughts on the use of digital technologies, the challenges and opportunities of that? When you are engaging with your customers, right, how are they reacting to the digital technologies that you are providing?
Yeah, so Prith, I think the appetite for this digitalization is massive, and so if you look at any of these customers of ours, talk about Shell for a moment, they have over 280 AI projects going on across their company. That's upstream, midstream, downstream, refineries, all the way to the retail side of things. And so what we're providing is really an AI platform, if you will, that can help accelerate deployment of hundreds of AI apps. As I mentioned, all the way from exploration to optimizing drilling to operations of refineries, all the way to customer engagement at the loyalty level at the gas station. And so the challenge is, how do you reduce the complexity from an IT perspective? And the complexity comes from 2 or 3 dimensions. One is the data of the corporation, probably like many of those represented here, are scattered across, hundreds and sometimes thousands of systems. And so the first challenge is, how do you unify and aggregate those data so you can actually see what a piece of equipment's doing, what a refinery is doing, what the end-to-end supply chain is doing. And that's challenge number one that we spent a good 5 years at the company addressing. And then the second challenge is operating machine learning models at scale. It turns out developing a machine learning model is only actually less than 5% of the problem of deploying it and operating at scale. And so at a company like Shell, where they're monitoring 500,000 sensitive control valves, that requires 2 million machine learning models operating and being managed and versioned in production, and that's a non-trivial challenge. And then all the other technologies that you have to glue together to do the data operations to support the machine learning models, and that basically requires a lot of programming, large teams to actually do that work. And what we've done is we've abstracted all of that so you can represent in a model, a concept that this audience is very familiar with, things like pipelines and compressors and valves and maintenance, etc. And then we're handling all of the underlying technical components and orchestration of those to actually manifest the behavior. So small teams of 10 engineers and data scientists can actually develop and deploy highly complex AI applications. And so at a company like Shell or 3M, it's teams of 50 or 100 people actually developing tens of these applications in a matter of months, and really fulfilling the transformation objective of the CEO, which is to get their organization on a digital path as quickly as possible, where AI is helping inform decisions across their organization. And that's frankly worth not just worth billions to these companies, but is the difference between competitive advantage and falling behind.
Absolutely. Thank you so much. That is great. Actually, that is a great lead into Sujit. So at Rockwell, I know that Sujit is driving a lot of these kind of innovative ideas. So Sujit, can you talk about some of the challenges and opportunities of digital at Rockwell?
Sure, Preet. I would say in the industrial space, Sudhi articulated really well what the challenges are in applying simulation. I would say that these are not showstopper challenges, these are opportunities. And I'll highlight 3 specifically. One is legacy, which Sudhi spoke about. There is a lot of legacy in the industrial space, and it's not going to go away. So if we connect a lot of legacy products that are out there, systems, collect the data, develop the models, digital models, share these models, that's a big opportunity. The second element in the industrial space is many assets tend to be bespoke. For example, furnaces are used in steel making and glass making, in many other applications. But when you go and look at each furnace, it's configured differently. It may have different capacities and so forth. However, if we can innovate a way to model furnaces and configure it very easily for different bespoke applications, that'll drive increased use of simulation. So that's a challenge within the industrial space. The first thing you'll hear from people is, we're different. Our equipment is different. Our application is different. We need to get beyond that. The third area I would identify is we need more talent and domain expertise, which is necessary in the industrial space. People who understand processes, who understand machines, if they can contribute to developing digital models and simulations that characterize how processes and machines work, then we can use those simulations in real time. So there's high level of interest and motivation today to develop digital models and simulation, because we can run these during real time, during operations, during maintenance. Because when you, as you spoke about earlier, if you look at the life cycle of an industrial automation system, design tends to be about 10%. Operate and maintain is the remaining 90%, 80, 90%. So if you can bring simulation into the operate and maintain cycles, then I think the value that it can deliver is tremendous. So I think there's great opportunity. The challenges really are opportunities for us to drive more innovation and make simulation more accepted in the industrial space.
Phenomenal response. Thank you so much.
Preet, can I just add a comment?
Absolutely.
to?
Sure, please.
I know it was not set up that way, but one of the things Sujit said is profound, because now if you look at the operate and maintain space in the manufacturing arena, the audience is not exactly the right audience for simulation, right? Typically, people with PhDs are the ones that have operated in the simulation space. But thanks to some of the evolution of technology, for example, visualization. Now with visualization, which is part of simulation, now we can have somebody who's probably got a high school diploma or above actually have the benefits of simulation. So I think it's a very important evolution of simulation, where it's no longer just the domain of PhDs and scientists, but you can, and engineers, but you can also percolate it downstream and drive the value and the quality of opportunities both for the people and the operations. So I just wanted to add that in.
Thank you very much. That was a great point. I'm glad you mentioned it. So let me kind of wrap up with this question with our friend from Honeywell, Suresh. When you talk about some of these digital technologies, the use of digital at Honeywell, I know we had a discussion on new product introductions and so on, but why don't you share your insights?
Yeah, I'm going to keep it short and crisp, as many of the panelists touched upon this topic. I think our biggest, what's holding us back in certain area, which is all about data, infrastructure, and tools, are pretty fragmented, and in certain areas it's proprietary. And for me, data, access to data, building the data model feeds into a simulate platform. I think that's pretty much my biggest number one. Second one, I would say, all these new skills are available, new technologies are available in front of us, native capabilities, skills and talent, and native capability to build, because there's not enough talent to actually come and build a model for us right away. You need algorithm developers. You need to actually have the people building those models at this juncture. So I think the war on talent and skill is going to be crucial. The lessons learned and opportunity for me doesn't start with the technology. The learnings that we have today is from our customer perspective, economics. If I want to go back and introduce 5G in their next generational distribution center, I think the customer would love to understand the P&L impact. So I think where we're really leading the discussion now is all about what's the problem that we're trying to solve, and how do we inject all these technologies, and do we understand the value prop? I think we are actually rewiring the whole company right now, because we're a technology company, and most probably me and my technology groups will jump into a technology conversation. We are resisting that, and we are really putting this new cover on value proposition and economics of our customers. So I think that's going to be an interesting zone that we're going to go through, because we all work with all the ecosystem partners. I think our customers want to understand how much would it impact their top line and bottom line. I think that's going to be a big evolutionary phase for all of us.
Fantastic. Thank you. So my final set of questions will be on the topic of digital twins. I think many of us talked about it during our earlier comments, but obviously the notion of digital twin is you have a physical asset, then you have a model of the asset, and you have a connection going back and forth. And the digital twin market is somewhere in the sort of 20 billion-ish, and it's the applications in manufacturing, it's the applications in automotive, in aerospace, defense, and many of the companies, oil and gas, and so on. So again, and I know many of you are working on those areas. So let me start with you, Sudhi, about sort of the role and use of digital twins to improve your operations and manufacturing. I know you're driving. So your thoughts on digital twins and usage as Stanley.
So I would break this up into a couple of categories. Number one is how can we create a digital twin at a plant level, right? So what we're doing is we're creating a digital twin, not just the assets, but it includes the processes as well. So we're using that now, especially going back to the crisis mode again, the discussion I spoke about. It is to understand capacity with a lot more granularity and a lot more specificity. Because there are assets that might not be performing really well. What's the point in keeping those running when you don't have a demand stagnate? When we have a demand stagnation like we do now. So there's a lot of opportunities now to really understand capacity. How do you schedule better, etc., without having to physically go to the factory and do all that work. So we're creating planned digital twins that are configurable. One of the panel members talked about it. So make it configurable. So that way we can plug and play, use a plug and play concept and plug it into the different factories. And then at the next level, we also believe that we can now use it to create a digital twin of the entire supply chain. Then you're obviously modeling the networks, you're modeling, the logistics and on and on. And so there are pockets of models already available. So the opportunity for us now is to connect that to create a full digital twin of the supply chain. At the lowest level, I've already talked about it, which is at the asset level. And we have tens and thousands of those assets, like I mentioned before, the molding assets and so on. So when you address all of these three different categories, I think what we will have is a very powerful ecosystem of models that can orchestrate with one another, which is obviously the nirvana state for Industry 4.0. So that's our vision. We've started on that, obviously going back to what Suresh was saying. End of the day, bottom line matters. So we're focusing on things that really drive value right now, but the vision is a lot broader than that.
Fantastic. So Ed, I know C3AI does a lot of work on digital twins and so on. I would like you to kind of talk about digital twins and especially how you're building digital twins for your customers, perhaps in the energy sector itself, right? You mentioned working for Shell, but then you just at the Transform event, you mentioned partnerships with Baker Hughes and other companies like Microsoft. So can you talk about digital twins that you are providing and your partnerships with different companies in the ecosystem? Ed?
Yeah, Prith, as you mentioned, we're partnering with domain specific companies. So Baker Hughes is obviously one of the leading oil field services providers. So they have lots of data on drilling and production optimization, yield optimization, and upstream, downstream operations. And then with charter customers like Shell and others, what we're doing is we're basically opening up a marketplace of models and digital twins. And so, for example, Shell can take one of our production optimization models or yield optimization models for one of their plants, from one of their refineries, and then train it on one of their large, super well operated refineries, and make that model available in a marketplace to an ecosystem. And so this again accelerates availability of these models, such that other customers can then subscribe to them. And so that's one dimension of the digital twins that we're basically making available. C3 provides a platform so that our customers can build their own models, build their own applications, we provide a suite of pre-built applications that we developed, for example, in oil and gas with Baker Hughes, that do reliability of plants, that do yield optimization, production scheduling. And then finally, our customers are also contributing and making their models available through a marketplace. So all this ecosystem really accelerates, the market and customers deploying AI and simulation into the broader market. Obviously, the developing partnership with Ansys is also a big component of the offering, if you will.
Fantastic. Thank you, Ed. Sort of that naturally leads into sort of Sujit at Rockwell, right? And so Sujit and I, we've been talking about some partnering area of digital twins for manufacturing. And so, Sujit, if you can talk about digital twins and sort of the ecosystem partnerships that you are putting together, right, with companies like PTC and Ansys and so on, right? And how you see both the design part and the operations part of digital twins.
I'll be happy to, Preet. I think the place to start is where both Sudhi and Suresh were talking about, which is business value. Digital twin is a term that's being used a lot, and it implies that for an asset, there is one digital model. But in reality, you may have several digital models. The digital model has to reflect the business value that you're trying to capture. For example, if you want predictive diagnostics of an asset, you need to design a model that mimics how the asset works. And with real-time data, you can predict when that asset can potentially fail. If you want prescriptive analytics, which means you actually prescribe when this asset needs to be maintained based on the data you're collecting, perhaps a physics-based model would make the most sense. So the initial point I want to make is the digital twin has to be designed with a business outcome in mind. And based on the business outcome, the digital twin implementation may be different. So there are many, many applications that we're looking at for digital twins. We talked about the value in the design phase, where it's mostly to do a lot of what-if analysis, optimize your design, optimize time to market for an asset. In the operate and maintain phases, you're using the same digital twin, the digital model, to reduce asset downtime, to lower the cost of production. So there are other benefits in the operate and maintain phases. But having said that, digital twin by itself can do a lot more than just predict what an asset does. With digital threads, we can now connect data from multiple digital twins. You can knit together a digital thread where you can go from CAD models to simulation to configuring machines and lines and actually running production and connecting all of those and keeping them active simultaneously. This is revolutionary, I think, for the future. It's transformational in what it can produce and what it can do. And it's going to take some time because, as was pointed out, people in the manufacturing sector are not experts in simulation by any means. However, as Sudhi correctly pointed out, new visualization technologies, whether it's augmented reality, 3D visualization, there are a whole host of really good visualization technologies that can get people to benefit from the output of digital twins and simulation. And that's truly exciting in the industrial space. So I'm going to stop there.
Absolutely. Wow, that's a great vision, and which kind of brings us to sort of user at Honeywell, right? So Suresh, I know you have been working on digital twins as well as Honeywell, but as a user of some of the technologies that we have heard from. So why don't you talk about digital twin usage at Honeywell?
I'm going to agree with all the panelists that have already touched upon what's digital twin, application of digital twin. I'm going to give probably a practical example. With this post-COVID-19, we just realized that remote operation, remote maintenance, remote service was the most important requirement, both internal to Honeywell and for our customers. We realized that even if you have had a connected tracks and if you have not really instrumented, meaning if you have not really built a model around it, I think as Sujit said, The models at this juncture, suddenly it went up to the peak because customers were calling us to say, we couldn't really have our folks operate our control tower. Can you remotely maintain? Can you remotely manage? And the first time we started seeing a big peak on connected assets in our warehouse automation play, the motors uptime, the systems uptime. The control tower wanted to really have a remote access when they couldn't really have their workers back in their warehouses and not in their factories. So the whole experimentation and POC that we all had around connected devices, connected assets, we all have the same value prop around uh, diagnostics and predictive monitoring of our assets, and downtime was a critical value proposition. Started really seeing the application, and it's picking up at this juncture. For us, it's getting to the point right now we should be able to run our labs, infrastructure, and operation of our customer real time. Simulation, digital twin, and the models for us to have a real-time closed-loop connection is going to be the most important aspects moving forward. So I agree with everything that they said, but I think practical application going to be our remote operation of our customers' assets moving forward.
Fantastic. Thank you, Suresh. So, Malik, I'm going to ask you to wrap up, right? At Ericsson, obviously, you are creating some of the IoT connected technologies through 5G, but what is sort of your view of digital twins at Ericsson?
Absolutely. Thanks, Preet. I think following what Suresh nicely put it, for us, digital twin is to really emulate end-to-end 5G live network, right? So in the case of 5G live network, you have got devices and all sorts of industrial IoT assets going over air interface towards the base stations and the connectivity elements, the packet core, fronthaul, backhaul, cloud edge. You got multiple components. So the idea of digital twin is to really integrate this and emulate all these components in an end-to-end manner to really replicate that live 5G network and see what is the performance of that live 5G network under various conditions. Conditions being congestion, traffic congestion, conditions being any security attacks on the network, conditions being any faults within the network. So how do we really test such kind of dynamic network conditions of a live network using that digital twin in a 5G network? That's one way to look at it. Then the second way to look at it is that if we need to add manufacturing over 5G network or healthcare over 5G network, every one of those verticals have got different compliances, different KPIs, different SLAs. How do we really predict such kind of KPIs and SLAs over 5G networks? So these are the two major use cases that we are thinking of replicating live 5G network using digital twins.
Thank you so much, Malik. And I want to thank all the panelists. This has been an amazing discussion. I would like to say that essentially what I've heard from you is that leveraging the power of engineering simulation, visionary companies that are represented on our panel, some Rockwell and Honeywell and Stanley Black & Decker and Ericsson and C3, you're all able to define your future, right? And the future of your customers and essentially entire industries. We talked about many, many industries as part of the conversations, from oil and gas to manufacturing and so on. I hope you all agree that the world needs innovation, right? And now more than ever in sort of the post-COVID days, right? And at the Simulation World Conference, right, where the entire global product development community, it was more than 20,000 of us, right, have come together to inspire each other and with the stories of agility and innovation and determination. I mean, I got personally extremely motivated just listening to you. I hope that you, all the attendees, you will leave energized and motivated, knowing that through simulation, you can engineer what's ahead. So once again, I want to thank all the panelists for sharing the insights and making this an absolutely amazing event. Wish you a good afternoon, good morning, good evening, depending on which region our attendees are listening. But thank you all panelists for your participation. Thank you. Bye-bye.
Thank you. Bye-bye.